Hello and welcome to Hot Math. In this edition of Hot Math, we're going to talk about systems of second degree equations. So let's get started. So we're going to solve for systems of lines and conics, solve for systems of circles and circles, solve for systems of conics, one non-circle. All right, so let's get started. All right, so this is the first set. We're going to solve for a system of lines and conics. You can see I have an ellipse here and a line. And there are really three possibilities I have for a line and an ellipse. I can have a line that intersects the ellipse in two spots. I can have a line, so there are two solutions. I can have a line that intersects the ellipse at one point, which means it's tangent to the ellipse. Or I can have a line that never touches the ellipse, in which case there are no solutions. So let's take, I have an equation for ellipse, x squared plus 3y squared minus 19y minus 23 is equal to 0, and then an equation for a line. And this is what we're going to do. All right, we're going to solve the linear equation for one variable. In this case, I'm going to solve for x. You can also solve for y. It doesn't matter. You have to choose which one is going to produce the easiest substitution value for you. All right, so I solve the linear equation for one variable. X is equal to 2y plus 3. Now I'm going to substitute that value for x or y into the equation for the conic and solve for the other variable. Right, so I'm going to substitute 2y plus 3 in for x squared. So 2y plus 3 squared plus 3y squared minus 19 minus 23 is equal to 0. I'm going to express the binomial, which means I'm going to FOIL it. End up with 4y squared plus 12y plus 9 plus 3y squared minus 19y minus 23, which is equal to 0. Simplify, combining like terms. Factor out the common factor from the terms. And I'm left with a quadratic, which I can factor to y minus 2 and y plus 1, which leaves me with two answers for y, 2 and negative 1. All right, so I'm going to take those two values and I'm going to substitute them back into the original linear equation to solve. And I have 2 times 2 plus 3 is equal to 7. So 7, 2. And by the way, be careful. You're substituting for y and solving for x. And my common mistake is to confuse which value is what at the end because I'm working quickly. So just be careful that when you're done, you have a coordinate which represents the proper placement of the values that you found for the variables. So it's 7, 2, and then substitute negative 1 in for y. Negative 2 plus 3 is 1. 1, negative 1 is the second point of intersection. All right, so we're going to move on. I'm going to give this to you as a problem which you can work out. I'm going to come back in a moment. All right, so I solve for one variable. I substitute that variable back in for y. I rewrote the equation. I expanded and then I simplified. We end up with 31x squared minus 124 after combining like terms. We're going to distribute out 31, left with x squared minus 4. It's a difference of two squares. I get x plus 2 and x minus 2. X is equal to plus or minus 2. So we're going to take that value, we're going to substitute it back in for x here, solve for y, and we get 210, and then negative 2, 2 is our answer. Okay, now we're going to solve for systems of circles. So we have three possibilities. We can have two circles that intersect at two spots, 2 points, two circles that are tangent to each other and touch each other at just 1 point. We're going to have two circles that never intersect, which means there are no solutions. The solution set is null. So we're going to take two circles, x squared plus y squared is equal to 20. X minus 5 squared plus y minus 5 squared is equal to 10. And this is going to be your example and your work. So what I want you to do now is to express the binomial. So FOIL the binomials. We're going to do some elimination. So go ahead and take care of that. Come back. All right, so I foiled the second equation for the circle, x squared minus 10x plus y squared minus 10y, and then I've rewritten all the constants on the right-hand side. And then I'm going to write the first equation below the second equation so I can eliminate the x squared and the y squared values. All right, so you end up with negative 10x minus 10y is equal to negative 60, which we can then simplify as x plus y is equal to 6. All right, so now we're going to use that equation The the singular linear equation back into one of the two equations for the circle. And we're going to solve for the other, or solve for one variable. So x plus y is equal to 6. We write it as a linear equation. Y is equal to 6 minus x. I'm going to substitute this value back in to the first equation for y. X squared plus 6 minus x squared is equal to 20. I'm going to then express the binomial. I'm going to combine like terms, factor out the common factor. I'm left with a quadratic, which I can factor into x minus 4 and x minus 2. I have two solutions, 4 and 2. From there, I'm going to substitute it back in for x into the original linear equation. If you substitute it back in for the circle, you're going to end up with two sets of possible answers which are incorrect. So substitute it back into the linear equation, 4, 2. So I get 4 plus y is equal to 6, y is equal to 2. So 4, 2 is one solution. 2 plus y is equal to 6, y is equal to 4. So second solution is 2, 4. All right, so last one, we're going to solve for systems of conics, one of which at least is a non-circle. All right, so I'm going to walk through an example with you. We're going to go through the same process of elimination that we did before, and this is pretty much set up for elimination right away. So I'm going to go ahead and eliminate the x squared variable, or x squared value. I end up with y squared plus y minus 6 is equal to 0. So we set up the system, and we use elimination to reduce to one variable. Now we're going to solve for that one variable by factoring this quadratic. Y is equal to negative 3 and 2 after factoring to y plus 3 times y minus 2. All right, so now we're going to take the value of negative 3. We're going to substitute it back into either equation and solve. X squared minus 3 squared minus 16x plus negative 3 plus 57 is equal to 0. I'm going to simplify, combine like terms. Again, I have a quadratic, which I'll factor. I end up with two solutions. So 9, negative 3, and 7, negative 3. All right, do the same thing for 2. Substitute 2 back in, or substitute 2 in, and solve for that value. And I end up with x squared minus 16x plus 63 is equal to 0, which factors to x minus 7 and x minus 9. So providing me with two solutions, 7, 2, 9, 2. So going back to our discussion about possible outcomes, we can have two conics, let's just say two ellipses that never intersect, so there's no solution. You can have two ellipses that meet at one point, so two tangent ellipses. So we have one possible solution. You can have two ellipses that meet at just 2 points, so we have two solutions. You can have an ellipse and a hyperbola that meet at 3 points. You can have 3 solutions. And then you can have an ellipse, two ellipses that meet at 4 points for 4 solutions. So those are the possible outcomes that you have for the intersection of two conics. All right, so I'm going to give you a practice problem. You can go ahead and solve this. I'll pause here. We'll come back and readdress this, and then we'll be done with this lesson. Okay, so I'm going to eliminate the y squared variable. It's already set up for you, and y. So I'm left with 9x squared plus 9x minus 108 is equal to 0. Factor out the 9, and then factor the quadratic. I end up with x is equal to negative 4 and 3. We're going through the same steps that we did before. Now I'm going to substitute. I had, as you recall, I had the solutions of negative 4 and 3. I'm going to substitute that negative 4 in first. Negative 4 and 3, express the values, simplify, distribute the 7 out, then factor the quadratic, and end up with negative 4, 5, and negative 4, 1 is one pair. And now I'm going to do the same thing for 3, substitute 3 in for x and solve for y. I'm going to express these values, simplify, distribute the common factor, solve for the quadratic, or factor for the quadratic, and end up with 3, 7, and 3, negative 3. Wow, that was at 10 minutes, 6.6 systems of second degree equations. So we had lines and conics, circles, and then conics and conics. That's it for this edition of Hot in Math. Come back and join us next time when we start talking a little bit more deeply about trigonometry in Chapter 8 and 9.